Hello, this is Mr. Wynn, and today's video will be base E in natural logarithms. So like pi and square root of 2, we have a number E. It's an irrational number. It's about 2.718. We call that the natural base or natural number. And you have an exponential function with E. We call it a natural base exponential function. So let me show you where that is in the calculator. On the calculator, E is, if you press second and the division sign, you get E. So again, it's about 2.718 and it keeps going forever. All right, we have two exponential functions, e to the x, e to the negative x. They're both used for continuous exponential growth or decay. The only difference is the exponent. If the exponent's positive, it's growth. If it's negative exponent, it's decay. And you can just log base e them, but we just abbreviate it as ln x. ln means log of e. So down there in black, I wrote log of e of something is the same thing as ln e of that something. Now, we don't put e next to ln. It's usually invisible. We just call it ln. All right, so those things right here are all the same. And exponentiating both sides and ln both sides is still allowed. Or logging both sides is still allowed. Right, so like before, it's just a new base, but same things apply. Change the following form from exponential to logarithmic. I'm going to try to bring the x down. So I could log base e both sides. Let me do it the old way first. All right, now here, log base e of e cancels, and really we just have this that goes down. We have x equals log base e of 8. That's fine, that works. Now let's do it the more correct way. I'm going to ln both sides. You only use ln when you have e. All right, so ln base e of e cancels. This still goes in front. So if x equals ln 8. Remember, ln is the same thing as log base e. All right, they're the same answer, but this is what you'll see more often. All right, on the bottom, change the form from logarithmic form to exponential form. I'm trying to get the word ln. So I'm going to exponentiate by using the correct base. Well, you only use ln with e. So I'm going to put e as the base for both sides. This cancels. I just have x on the left equals e squared. That's it. It's the same trick as before. We still can log or ln both sides, and we can also exponentiate both sides. We can also condense or expand natural logs with the same properties as before. Mainly, you can bring exponents down or up if you're taking a logarithm or natural log. If you're adding same log bases, that's really multiplying. And if you're subtracting same log bases, that's really division. All right, so here, let me put this 2 back up here. This 5 back up here. So really have ln of 10 plus ln of 3 squared minus ln of x to the 5th power. All right, also, let's get rid of any exponents if we can. ln of 3 squared is the same as ln of 9, because 3 times 3 is 9. All right, now there's something else to reduce. Let me combine them. Since the first two are being added, that means you're going to multiply them. So 10 times 9. Since the second thing, last thing is being divided, that means division, divided by x to the 5th. All right, so that's what we have now. And if I fix it, that's ln of 90 on top, divided by x to the 5th on bottom. That is my answer. All right, so just put the numbers back up top for exponents, and then I just did the product property. If you add same bases, that's really multiplying them. And then if you subtract same bases, logarithms, then that's division. All right, we solve equations and inequalities the same way as before. So I can only, let's see, x is an exponent. I want to bring it down by lning both sides. But you can only ln both sides when there's a single term on both. So first I'm going to add this 5 over. All right, so I'm at 4e to the negative 2x equals 8. All right, now I want to ln e, not ln 4, so I have to divide by 4, because that's 4 times e to the exponent. So now we're at e to the negative 2 over x, 2 times x equals 2. Now I can ln both sides. So I ln both sides, I get this. All right, remember this cancels. And this technically drops down. I have negative 2x equals ln of 2. Now, I want to solve for x. I'm going to divide both sides by negative 2. That's it. So x equals ln of 2 divided by negative 2. If you want the decimal answer, you just type in the calculator. So let's see what that is. It's a fraction, ln of 2. Now notice ln is on the left underneath the log, and you see each x is on top of it if you do a second. And negative 2 on bottom. Here's my answer, negative 0.3466. Negative 0.3466, all right. If you want the decimal. All right, so either one. All right, here's the inequality, same thing. Now we have multiple steps here. I'm gonna use the logarithm property. You have an exponent, you're allowed to bring it to the front. So I really have 4 times the ln of this thing. It's less than 4. I'm going to divide both sides by 4. So now I have the ln of x minus 8. It's less than 1. All right, I'm going to try and get rid of the word ln. So I'm going to exponential both sides by using base e. That cancels. So I have x minus 8. It's less than e to the first power, which if it's first power, we don't need that. Solve for x by adding 1. Or sorry, adding 8. All right, so x is less than e plus 8. That's our answer. Now, if you want the decimal, just type in the calculator. Remember, e plus 8, so second this, plus 8, it should be 10.7183. 10.7183. All right, same thing. Now, we could have just gone straight to eating both sides, so let me do this. That's my way of solving it. Your other step was to leave that 4 up there and go straight to try and get rid of the word ln. If I get rid of the word ln, then I just e both sides like before. This cancels. I have x minus 8 to the 4th power is less than e to the 4th power. You can cube root it. Sorry, not cube root. 4th root it both sides. Right, the 4th root of something 4th cancels. So this left side is just x minus 8. The 4th root of e to the 4th is just e. And then add 8 again. X is less than e plus 8. Same answer. All right, so there's more than one way to do these. As long as you follow the rules correctly, you can rewrite them and make problems easier or harder. All right, and the last problem. Continuously compounded interest. So remember in the past, we could compound things yearly, semi-yearly, monthly, daily, hourly, things like that. The more you compound your interest per year, the more money you make. So the best is compounding it continuous. Every split second, you check the interest and add it. All right. When you do that, we use this formula. A equals P e to the RT. So if y'all can't see that, A P e to the RT. A will be your total amount. P is the principal amount, meaning the starting amount. E is E. R is your interest rate. And T is your time in years. So everything's always in time of years. Now the right side, the logarithm thing, is the same equation. They just ln both sides, but we don't really use it too much. So example 5. When Lily was born, her grandparents put away $3,000 in a savings account. That account paid 4% interest, compounding continuously. So how much is there after 10 years? This is just plugging straight into the formula. So A equals P e to the RT. We're trying to figure out how much A is. How much is after 10 years? P, the initial amount, was 3,000. R is 4%. Remember, as decimal is 0.04 times T. T is 10. All I use put in my calculator. Then I'm done there. 3,000 times, 3,000 times E. That's what I forgot. Times E to the 0.04 times 10. So E to the 0.04 times 10 gives me this 4475.47. 4475.47. All right, so if I put $3,000 away and I wait 10 years, it goes to 4,475, almost 1,500 more, almost 50% gain. That's not bad. All right, how long will it take for that to become 10,000, or at least 10,000? So, same formula A. Now, at least 10,000 means I have to use 10,000 or more. P to the RT. I fill in our numbers. 10,000 for A. 1, 2, 3. Our initial amount is still 3,000. Still E, it's still 4%. We're trying to find T, the time. So we're going to have to solve for T. It's an exponent. We're bringing down by doing logarithms for ln, since we have E. But let's first get rid of 3,000 by dividing it. All right, so I am at, and if I reduce that, that's go like this. 10 over 3 is greater than e to the 0.04 t. Right, I'm going to ln both sides. So ln of 10 over 3, that's stuck in this ln, should be greater than ln of e to the 0.04 t. Well, this cancels, this goes in front. So I'm running out of space. That's all right. So I'm at ln of 10 over 3 is greater than 0.04 t. All I'm going to do is divide by 0.04, and I'm done. I'll put in my calculator. So t is less than some number. Greater than some number. My bad. All right. It's a fraction. ln of a fraction. 10 over 3. I'm going to divide it by 0.04. I get 30 points. I'll do 2 decimals. 0.10 years. 30.10. All right, so I got to wait 30 years, at least 30 years for it to hit 10,000. So more than 30 years means more than $10,000. That's my answer. So it's just a problem where you had to solve the exponent by doing logarithms. All right, here's your practice problem. Solve for e. That should be the exact answer, ln 9 over 4. Shouldn't need a calculator for that. But if you want the decimal, then you use a calculator. All right, if you can do that, you should be fine for class. Again, this is Mr. Wynn. Thanks for watching. See you later. Bye.